ads and news articles about synthetic gem quality diamonds are becoming more common today, and your customers are bound to see them. This podcast is designed to help you answer your customers' questions about synthetic diamonds. Diamond is made of carbon atoms arranged in a cubic pattern, and so is synthetic diamond. They both have essentially the same chemical composition and crystal structure, so synthetic diamond is diamond. But natural diamonds grew deep in the earth and were brought to the surface by a special type of volcanic eruption, and synthetic diamonds are grown in a laboratory. HPHT equipment simulates the high temperature and high pressure found deep in the earth where natural diamonds grow to produce synthetic diamonds. Most of the synthetic diamonds on the market today are produced by HPHT processes. With chemical vapor deposition, a chamber is filled with hot plasma, an electrically charged gas such as methane or CH4, which contains one carbon atom for 4 hydrogen atoms. Microwaves energize the plasma, breaking the atoms apart, which allows the now free carbon atoms to attach to seed crystals. The CVD process is mainly used to create thin diamond crystals and coatings for industrial purposes, but some gem-quality CVD synthetic diamonds are being sold today. In the past, CVD stones have been small, but sizes will continue to get larger as technology improves.
If you took a natural fancy yellow stone that would retail for say $20,000, ours would sell for about $6,000. So we're 30 to 40% of the price of a natural yellow stone.
Synthetic diamonds are less expensive than natural diamonds of the same quality. The equipment and process used to grow synthetic diamonds is expensive. It takes many hours to grow a crystal large enough to cut a 1-carat stone, but it is still not as expensive as mining natural diamonds. Mining a diamond pipe is a massive undertaking, requiring huge investments in equipment and time. All the dirt in this enormous truck might produce only a handful of diamonds, and many of those are industrial quality. And eventually, even the most productive mines will be worked out. So, natural diamonds are a limited, finite resource, while synthetic diamonds can be made endlessly. Diamond is often called the king of gems. Its luster, brightness, and fire combine to give it a special beauty that is only approached by gems that imitate diamond, like CZ and synthetic moissanite, because these simulants have very different properties than diamond. CZ, for example, does not take as fine a polish as diamond, so a CZ looks dull next to a well-polished diamond. And CZ is more dense than diamond, so CZs are heavier than diamonds of the same size. This can make CZ earrings less comfortable to wear than diamond earrings. Synthetic moissanite has a much higher dispersion than diamond, so it shows more fire. It is also doubly refractive. Here you can see doubling of the back facets. Other older simulants are even less convincing substitutes for diamond. Synthetic diamonds, on the other hand, have the same optical and physical properties as natural diamonds. Their brightness, fire, and durability are exactly the same. However, synthetic diamonds are more expensive to produce than simulants like CZ and synthetic moissanite.
It's actually much more expensive to produce. The other processes, the materials that they use are a lot less expensive. It can be done quicker, it can be done in mass scale. With our machines, as I mentioned, we can grow up to 8 stones in at one time, but they end up being smaller. So we're concentrating on growing one stone at a time. The process that we're using right now to grow the yellow stones can range anywhere from 3 to 4 days, and we'll end up with on average, a 3-carat piece of rough. I would feel that by the end of this year, we should be closer to 4 carats in our average size.
Although synthetic diamonds are more expensive to produce than simulants like CZ and synthetic moissanite, the properties of synthetic diamond are exactly the same as natural diamond, and synthetic diamonds can still be a more affordable option than natural diamonds.
Those other moissanite and cubic zirconia are not diamond. This is 100% diamond. There's no ands, ifs, or buts about it. So what people are buying is a diamond here, not a simulant or a copy of a diamond or something that looks similar to a diamond. This is in fact diamond. We use two different terms, and it depends on the audience that we're talking to. If we're talking to the industry or it's a group like the GIA, we use the term laboratory grown because we feel there's no ambiguity about that. You understand exactly what it is. Cultured, on the other hand, is a term that the consumer has gotten used to with regards to cultured pearl, where there's been man's intervention in the process. So from a marketing perspective to the consumer, we use cultured diamonds, but we will always use, there will always be another disclosure. We don't use cultured as our disclosure language. We will say, for example, Genesis cultured diamonds are diamonds grown by man, or something along that line. So we don't necessarily believe that cultured is a good term to use to disclose the origin of the product, but we believe it's a term that the consumer understands that there's been man's intervention in the process.
Although you may see the term cultured used in the marketing of some synthetic diamonds, this term is not adequate when disclosing synthetic diamond to a customer. Instead, use terms like synthetic, man-made, or laboratory-grown so that it is absolutely clear to anyone buying a synthetic diamond that it was grown by man in a laboratory. Synthetic diamonds were first produced by General Electric in 1955, but up until recently, companies were only selling industrial-quality synthetic diamonds. Although the GIA lab tested several gem-quality synthetic diamonds in 1970 and more in the 1980s, they were not sold commercially. Russia began selling very limited numbers of gem-quality synthetic diamonds in the 1990s. But in the last few years, technology has advanced to where synthetic diamond can be produced in the quantities, sizes, quality, and price to make them marketable as an alternative to natural diamonds. Natural diamonds usually contain inclusions, and so do most synthetic diamonds, with clarity grades ranging from VVS to I. Colorless and near-colorless synthetic diamonds have recently entered the market. Near-colorless stones are light yellow or brown, just like natural diamonds. Even more common, however, are synthetic diamonds in vibrant colors. Fancy-colored natural diamonds are more rare than near-colorless stones, and usually more expensive, if you can even find one in the color, size, and shape that you want. So, synthetic diamonds offer all the beauty of a natural fancy-colored diamond, with a growing supply in a range of sizes and at a substantially more affordable price. Chatham Created Gems is marketing synthetic diamonds in a range of color. However, Genesis has currently chosen only to sell yellow synthetic diamonds.
We're coming into a very traditional industry, and we felt that with the yellows and oranges that it was a way to kind of break the ice and get people comfortable with the product. Also, you take any trade magazine today and open it up, and every second ad has yellow stones in it. There's a lot of demand for those type of stones right now. I don't believe there's enough product to meet the demand that's out there. So we're augmenting the natural production. In the future, we will be coming out with the other colors, again, once the industry has gotten comfortable with the yellows.
The price of synthetic diamonds reflects the cost of producing them. Yellow synthetic diamonds are somewhat easier to produce than other colors, and they are the most commonly produced. Some colors require radiation or a combination of radiation and annealing. The extra processing adds to the stone's price. And it takes longer to grow larger diamonds than smaller ones, so it costs the producers more to grow them. Because synthetic diamonds actually are diamonds, just grown by man, the GIA laboratory grades them and issues reports on color, clarity, and other quality factors. Because of the rarity of high-clarity natural diamonds, their clarity grades are subdivided. There's less difference in price between clarity grades for synthetic diamonds, however, so the GIA lab does not subdivide the grades. But a grade of very slightly included means the synthetic diamond would be either a VS1 or VS2 if it were natural. Cut, color, and finish are graded exactly the same way as natural diamonds. Many producers inscribe their synthetic diamonds with a serial number or other identifying notation, but not all synthetic diamonds have an inscription. However, there are other identifying characteristics. The laboratory processes used to grow synthetic diamonds create an environment that allows carbon to crystallize as diamond, but it is not the same as 100 miles beneath the surface of the Earth where natural diamonds form. As a result, HPHT, CVD, and natural diamonds all contain different characteristics that can be used to identify them. For example, synthetic diamonds may contain opaque metallic inclusions left over from the material they grew in. These metallic flux inclusions are not seen in natural diamonds. The different growing environments also result in different external forms, like this cuboctahedron, which are different from the shape seen in natural diamond crystals. Just as the outer form of the synthetic diamond looks different, some synthetic diamonds contain distinctive growth sectors. This often results in color zoning and angular patterns not seen in natural diamonds that correspond to the different growth sectors. Growth sectors in synthetic diamond can also cause angular patterns visible under standard ultraviolet light. A fourfold fluorescent pattern is common, often in a cross shape. Natural diamonds also fluoresce, but the fluorescence is usually evenly distributed. There are a number of differences, but if there is any doubt, the GIA lab has sophisticated equipment that can detect even very subtle indications of how the diamond formed, whether by HPHT, CVD, or by nature. Unlike synthetic diamonds, which were grown in a laboratory maybe only a few months ago, there is something extraordinary about a stone that grew around 100 miles beneath the surface of the Earth. Perhaps even more extraordinary, natural diamonds grew a long, long time ago. Scientists place the age of the youngest natural diamond they've tested to be 600 million years old. The oldest is 3.3 billion years old. That means all these natural diamonds formed at a time when only the most primitive forms of life lived on the Earth, giving even more meaning to the words, "a diamond is forever." So synthetic diamonds can never replace the romance and mystery that comes from owning a gem that formed by the mysterious forces of nature millions of years before dinosaurs or cavemen walked the earth. But synthetic diamonds offer a lower price alternative to natural diamonds due to the magic of modern science, and some customers find the technology used to create these lab-grown diamonds captivating.